Alright, so let's say you're given this potential energy equation here, and the question says to find the force of gravity assuming that potential energy for gravity is mgy, and also assuming that gravity acts in all three dimensions, x, y, and z. To start, we know from last time in 1D, force can be written by this, where dx is a small displacement in the x direction, and du is the corresponding small change in the potential energy. But how does this change in 3D? In the same way, we can write the force in the y direction and the force in the z direction like so. However, since u may depend on x, y, or z, we need to compute the derivative of u with respect to y while keeping x and z constant. So basically when we're computing this, if there's x and z variables in the expression, we treat these variables as constants. So these can just be treated as random numbers. This type of derivative is called a partial derivative. So it can be rewritten in this form where this sign represents the partial. In this case, it tells us to vary y. So take the derivative with respect to y while considering all other variables constant. Therefore, in 3D, we can write the force vectors in all three directions like so. And we can use this to write a force vector reflecting all three components in this form here, where I, j, and k are unit vectors. So I points in the x direction, j points in the y direction, and this is supposed to be k pointing in the z direction. We can also identify that this is going to be our force in the x, this is our force in the y, and then this is our force in the z. This can be also rewritten in terms of the gradient. This is the definition of the gradient here. If we take our force vector and pull out the negative sign and the potential, this value here should represent our gradient. I forgot to take out the minus sign in the expression. Sorry about that, guys. But in total, force can be written in this form here. So this is how we can find the force of a 3D potential energy function. It applies to our example. This is our potential energy function here, and this is our force equation. Plug in u equal to mgy. We can plug in our definition for the gradient, distribute the mgy into the bracket like so, and then we can evaluate each term starting with the partial derivative of x. So we can see that all the values in the integral are constant. Since we're taking the derivative with respect to x, the y is going to be treated as a constant. The total partial derivative is equal to 0, and this is the same for the partial derivative in the z direction of this function. For the partial derivative with respect to y, we can take out the mg. The partial derivative of y is just 1, and so we get mg for the answer for that. So we can plug all these in, and then we find our final answer here for the force. And this is the force felt by gravity, and this makes sense because if we remember, j hat points in the y direction, and negative means it's pointing down, so this makes sense since gravity always points down.